Yeah, welcome everyone. I've been attending Reject since Valencia, so this is fourth time, and I had a couple of lightning talks, but this is the first time that I'm doing a longer presentation. So today I'll talk about Kyverno. Who are using it already? Oh, okay. Um, who is planning to use or never heard of it or tried it? You are definitely in the right room. For the others, so this will be more like an introduction talk. I mean, you're always welcome to join, of course, but just to make or set the expectations, so you might also get bored a little bit. So my name is Koray. I work for Kubermatic as a consultant. We do consultancy trainings and the other stuff. I'm Turkish, living in Istanbul. I'm CNCF ambassador since the last year, and Kubastronaut. So yeah, I have a bunch of certificates. I am Kubernetes contributor on Kate's infra, also on API Snoop, where we do the conformance testing for Kubernetes distributions. I'm also organizer for KCD Istanbul and DevOps Days Istanbul as of this year. So here are my profiles and stuff. You can, if you want to connect, you're always welcome. So before I will jump to Kyverno stuff, I just want to refresh the knowledge about Kubernetes. So in Kubernetes, we have two main components, the control plane and the worker nodes. And in the control plane, we have controller manager, scheduler, cloud controller manager to create the cloud resources, API server, and the etcd, so the database. And also on the worker side, we have the kube proxy, kubelet, and the runtime where we run our workloads. And using kubectl commands or like the dashboards, like Kubernetes dashboards and other stuff, you can interact with your cluster. The important point here is the API server is the key or the entrance point to the cluster. All the requests goes through API server, and API server is the only component who can write to etcd. So all different components, if they want to change something in the cluster, all the traffic goes through the API server. So how does the API server take care of the access control stuff? When you run a kubectl command or any pod running inside the cluster, want to make some changes or access want to get some information out of it, there are 3 steps. The first one is the authentication, so you must be a valid user in the system. And then the authorization, you must have the permissions to do that action, reading the pods, creating a new pod, deleting a deployment, whatever that is. And then the third step is the admission controls. I will come to that admission control part, and if they are all successful, then the data is written on etcd, and then the rest is the magic of the Kubernetes is going from the etcd side. So, but to be able to make a change, you have to go through those 3 steps. And for the admission controllers, Kubernetes already provides some compiled-in ones, like default storage class or limit ranger. Yeah, put it twice, but you can say that, yeah, there must be a default storage class in this cluster, or you can put limit ranges per namespaces, etc. And also, the other part is that where you have the puzzle thingy, or you can make different decisions for your cluster, is the dynamic admission controllers. And these are, there are 2 parts or 2 types of those dynamic ones. They can be validating, so you can just check the incoming request. If it is a valid request or not, you can reject it. You can say that no, you cannot create a pod without resource requests or resource limits. You can do such stuff, or you can mutate the incoming request, saying that okay, this request do not have resource limits, but there must be some, so I define resource limits for this incoming deployment. You can do such stuff as well with dynamic admission controllers. So, all in all, what is Kyverno then? It's Greek for govern, and you can create policies as Kubernetes resources. So you probably also heard of OPA, where it's another policy engine and gatekeeper. The problem or downside of OPA is that you need to learn another language called Rego. I'm not saying that it's a bad thing, but it's something that you need to invest time, or your team needs to invest time on it. But with Kyverno, you continue with all YAML or Kubernetes native stuff. Again, not saying that YAML is great, but it's in our daily life, so it's there already, so you don't need to spend much more time with it. Using Kyverno, you can validate and mutate things, mutate requests, incoming requests, and you can also generate or clean up some resources using Kyverno policies, which I will show some examples as well. For example, you can also verify container images for software supply chain security, where you can check the signature of the resources or SBOMs, etc., etc. You can do that sort of stuff. Kyverno is able to inspect the metadata of the images, so you can define things like, yeah, I don't want to run a container which was built older than 6 months ago. So you always want to have new images to be running in your system. You can synchronize configurations across namespaces. Whenever there is a new namespace, you can create some stuff on that namespace. And it also comes with a CLI tool where you can test the policies in advance. For example, in your pipeline, whenever there will be a new deployment, you can first check if it is valid request for your policies in advance, and then maybe stop the pipeline there, asking for people to change that deployment or some other resources in this new request. So we deployed Kyverno, we created some policies, we are all secure. That's great. And if we check the high-level architecture of things a little bit again with Kyverno, or where does it fit in the picture? So whenever there is a new request coming into the API server, there is a HTTP handler. It does the, again, authorization and authentication and authorization stuff. And then it first runs the mutating admission controls. So if you want to change things, again, if you want to deploy some default values for resource requests or limits, or if you want to add some new labels to the incoming deployments, incoming, I don't know, whatever you want to create there, or annotate some stuff, you can do the mutation. Then with the mutating admission, the admission review and the whole Kyverno part with the webhook and the engine, everything runs. So in the end, the API server calls a webhook, another process. The magic runs in the Kyverno engine and responds back a success or fail to API server. If it is successful, then there will be a schema validation where if your YAML, everything is correct or not, after mutating especially. And then the validating admission webhook is called again. So this time you are checking if the incoming request is valid according to your policies or not. again, you can say that, yeah, you cannot run this image, you cannot deploy a container from this repository, you cannot deploy an old image, or you cannot deploy an image with the latest tag. You can define those kind of policies, and the validation webhook will check for those. Again, after the Kyverno magic, things are committed to etcd, and then this time the Kubernetes magic is running. The deployments are created. The controller managers take care of the whole stuff. Kubernetes runs the container, etc. There are some background processes, like policy reports and everything, where they run within the system all the time and create some reports like, hey, you have this policy and this deployment is not, it's against this policy, so you need to take care of some action. But those background policies do not, like for example, they do not delete your deployment, or they do not change your deployment. They only report saying that this is against the policy, you need to take some sort of action. Another thing is that, as you can imagine from this whole flow, Kyverno, or all those webhooks are triggered when there's a new request. So if you have already deployed some stuff on the cluster, they will continue running. They might be reported by those background scan reports and the others, but Kyverno will not take a corrective action to change those. And yeah, as long as there's a new request, things will be checked, and then will be either rejected or mutated, or whatever action you defined in your policy. So the problem with the webhooks is that, especially in this case, if the webhook is down, effectively your API server is down. If it cannot get an answer from the Kyverno webhook, then the whole thing will fail. Like it will just time out, and your kubectl command will fail. It won't be able to create the deployment or whatever resource you are trying to create. So first of all, it's quite important to have a high available, like multi-pod or multi-replica deployment for Kyverno. It's really in a critical path, I would say. Yeah, I mean, we had a customer where, yeah, they had issues with the Kyverno, and then they had quite some downtime. I mean, of course, the downtime is on the API server side, so the workloads are still going. I mean, I don't know if you, yeah, the downtime definition for Kubernetes is a little bit different, but at least it's downtime on the control plane side. Of course, the workloads will continue running. There is also a configuration for that. It's called failure policy. You can say that, yeah, okay, if you cannot get an answer, you can just allow the request. That's also possible. So if Kyverno is down, API server will continue running, but then your policies will not be applied. So if you have mutating policies, then at some point after the Kyverno is up again, you need to manually fix those mutations, or also for the validations, they won't be working. So yeah, the values are ignore and fail, and I think the default is the fail, so be careful about that part. I would like to show some policies, some examples. For example, I think these are basic. These are the things that we discuss in like every security training, or if you check the security blogs, it will say that, hey, you should not allow privileged containers. Of course, there are some exceptions for that, especially some daemon sets need those things within your cluster, but for the user workloads, you should not allow it. And you can say that, again, in a YAML format, if containers or init containers or ephemeral containers, if they have the security context privilege defined, they have to be false. This one is, so again, validate, do you see this one? Yeah, so this is a validation admission, and also the action is audit. So you can have two types of actions. You can audit those, you can just write them in a log, and the request will be accepted as well. So in this example, it will create the deployment or the pod, but it will audit it. The validation failure action could also be enforced, and then in this case, it will just give this message saying that privilege mode is disallowed, you cannot define those fields as true. Or yeah, you need to set it to false. So that was one thing, and these are also cluster policies, so this is valid for the whole cluster. You can also create policies which are namespaced in this case, so you can say that in this namespace I don't allow this, in that namespace I don't allow that, etc. So you can create different policies per namespace too. Yeah, I already said this, blocks tail images, so it can check the image metadata and saying that images that are built more than 6 months ago, they are not allowed. But again, today you deploy it, after 6-7 months, if you haven't updated it, it will continue running, and Kyverno will report it at some point saying that, hey, there's an image running in the cluster, it's older than 6 months, but it will continue running. Kyverno will not take any action to change it, but it will report to you. That's also something you need to consider. This is something I prepared for a customer, but we did not apply it for different reasons. But you can also make, as I said, you can do mutations, and you can also do some sort of calculations or arithmetic things there. So this one sets the CPU limits to less than 10%, to make them, how do you say, reduce 10%. So it gets them, divides them by 10, and multiplies by 9. So if you requested 100 millicores, this will mutate it to 90 millicores and apply it this way. So you can also do that sort of different arithmetic calculations as well, if you need to. I think other than validation and mutation, the generation part is also important. In this one, for example, whenever there will be a new namespace created, it will create a default deny rule for that namespace. So you can make sure that whoever in the cluster creates a new namespace, they will have this or some other network policies in place already. So yeah, I think that's also quite important for, that sort of actions are quite important for the admins or SREs or people who are administrating that cluster. Yeah, another one is so this is another network policy to allow DNS. So the first one just puts the deny all, and then the other one allows the DNS to the kube system namespace. So with these two cluster policies, whenever there's a new namespace, those will be created by default. You don't need to take any other action. And another one, this is also like a best practices thingy, right? You should not run any deployment or any workload in the default namespace. That's what's said on the book. So, but you cannot make sure that people follow it, but you can force them to saying that, hey, default namespace is not allowed, you need to create your namespace, and then blah, blah, blah. Kyverno website has a lot of examples as policies. You can check them out. I think it's a nice place, and people just put it there as open source. There are many examples there. There is another thing called validating admission policy, which is, I think, alpha was on 1.26 Kubernetes, and since 1.30 it's stable. So you can also define those. I mean, this is like native Kubernetes, so you don't have to have anything else with the validating admission policy, but it's only for validation. So it doesn't do mutating, it doesn't do generate. But it's also there, so if you only want to do that sort of thing, you even don't need to install Kubernetes, but continue with the native. You don't need to deploy Kyverno. You can continue with the Kubernetes objects. So, demo time. I will use Killer Coda. The things are there, and then you can also use it as well. I think I didn't need to do this, so 1 second. In here, yes, that's great. So, the installation, you can do it from the install YAML just directly, but this will have one replica thingy. But if you want to have a high available deployment, yeah, you can do it with Helm with multiple replicas, or you can just increase the number of replicas for your installation. So this will create bunch of custom resource definitions, service accounts, and everything, the roles. Yeah. Let's check the CRDs. So you will have admission reports, background scan reports, cleanup policies, and cluster policies. As I said, cluster policies are for the whole cluster, but you can also have namespaced policies too. Let's check the Kyverno namespace. Is it visible, or should I increase the size, font size?
Bigger is always better.
Okay. This, I think, better. No, this one. Pods. So we have the admission controller, background controller, cleanup controller, and the reports controller. And let's wait for the pods to up and running. Okay, cool. Yeah, all of them are running now. So I have a private Docker hub to install Nginx, which has latest tag 125.1, and that's it so far. I need to export Docker user. I've already defined Docker path. So I want to create a secret called recred. So because I want to deploy some images from that private repo, and I also want to use this repo for some other purposes. Then, so for the image metadata to be able to check it, Kyverno itself will need to access to the repo. So the recred is for the kubelet to be able to download the image, but if you want to check for the image metadata, then Kyverno will need to access to this repo, and then you also need to provide this image pool secret to it as well, to its definition. So I will also do that. I just patched it to say that, hey, this is my registry credentials. Use those if you want to check the image, which will, yeah, I will use it in a second. I also don't have, I think I won't have time for questions, but I'll be around. And that's always.
Take a question now.
Do you have any questions? Meanwhile? No? Yeah? Yeah.
Oh, we have
Oh.
a question here.
Thanks very much. We've just started using this the last couple of weeks, and what advice would you have about kind of policy sprawl where the answer to everything seems to be a Kyverno policy?
Policy, sorry?
Policy sprawl, kind of where the answer to every problem seems to be a policy. It does seem to be the case, to be fair.
Yeah, I mean, I think the policies and I'm a consultant, so I'll give you the default answer. It depends for the organization, for what you want to do or how you want to do it. So again, there are some how do you say, best implementations, best the things that you need to do, and there are many policies around those. But what you want to apply there or how you want to apply those is, I think, totally depends on what you want to try. And also, I think what you define on your test environment and production environment would be different. So that's also another thing to consider. But I don't have a specific answer to for that. I'm sorry. Yeah. Yeah. Back to the demo. So I have a policy to sync secrets. So I want to actually sync this registry credential to every namespace whenever I create it. So that means whenever someone wants to deploy something to their namespace, I mean, they create a new namespace, they want to deploy this Nginx image or an image from the private repo, they will have the registry credentials in the cluster already. They won't need to define it on their own. That's the idea, or that's what we want to try. So all I'm saying is that whenever there's a new namespace, generate the secret called recred and synchronize it from the Kyverno namespace called recred secret. So it will just copy it whenever there will be a new namespace, or that's the whole idea. Let's create it, and if I check the cluster policy, it's there. So I'm just creating a dev namespace here, and if I check the secrets, the record is already created there. And if I also check the annotation, the labels, you will see that this was created by Kyverno itself. So I did not do it. So this is a very handful thing, especially for dev environments or for your customers. They will not need to deal with any secrets or something. The next is that, yeah, I want to deploy this. I'm using the latest image now in that private repo. So this is my private repo. Let's create this. It's created, and if I check the dev namespace, sorry, I need to show this one again. So I didn't use any secrets like image pool secrets thingy, and if I check the pod now, it's pulled back off because it cannot access to my private repo. So I have another one saying that whenever there is a pod created, patch it, and saying that, and if the image is this, like in my private repository, add this pool secrets thingy to the deployment. Let's apply this. Let's apply this. And I will replace it. I'm replacing it because it won't change anything on the running thing. I need to create this request from scratch. And if I check the pods now, it's running, and you will see that it added the record here. So again, you create the register credentials automated. You add the image pool secret automated, so your customers or clients will not. They don't need to know anything about it. You automated this already on your cluster. And I don't have a time, but I really need to show this. I'm so sorry. So let's export a tag, and I want to build a new Nginx image with this tag. And so you are able to use call sign with Kyverno as well. That's also a nice feature, especially for software supply chain. So I will not go into details how call sign works, etc. But yeah, I just create a new key pair for call sign, and with this key pair, I'm signing my new image. Yes, yes. So what happens here is that, so it pushed the signature to here, and if I check the tags again in my private repo, so I created this tag. It was created like a minute ago, and also created the signature there. So I have the signature as well. So I have a new policy called verify images, and I'm saying that using this call sign key pair, which I just created, verify those images. Make sure that those are signed with this key. Otherwise, do not deploy them. That's the whole idea. So if I delete and recreate this deployment, it was still the latest image. It's still the latest image. I didn't change the deployment. And if created, really? Okay. No, that shouldn't have happened. Pause. Dev. Because I didn't apply the policy, right? Sorry. Yeah, without the policy, it won't work, of course. Delete. Create again. Yeah, it says that, yeah, this is not signed. This is the latest image. It doesn't have a signature. That is true. Now I'm changing or patching the deployment. Now I will use my new tag, and let's create this. And now it's created. And if you check the output, you will see that now it's using this new image, and yeah, there is also a notation saying that, yeah, Kyverno verified that image. That's also demo. I did fast, but yeah, I think you got the the idea. I think we don't have time for questions, but I'll be around all the time. Today, so just you can ask anything. And there are a lot of resources around Kyverno. I think it's a good practice to use it. Yeah, thank you very much.